Today we're going to look at solving radical equations. Radical is the official mathematical name for this symbol right here. This symbol right here might also be called a square root sign. So we're going to solve equations that have square root signs. But before we solve it, by the way, is this an equation? This first problem right here? It doesn't have an equal sign in it. It's not an equation, it's an expression. And it's just a couple of things to remind you about before we actually have the equations. Do you know what the square root of x times another square root of x is? Well, x times x would be x squared. And what's the square root of x squared? The square and the square root cancel each other out. In problem number 2, or example number 2, the square and the square root cancel each other out. What is this telling me to do? I'm going to come over here. I'm not solving it. I'm just multiplying it out. I can't solve it because I don't have an equal to something. So I want to have x plus 1 squared. That's when we use a box problem. X squared and 1x and 1x and 1 times 1 is 1. And you would combine like terms. Now this next one is a little bit different. We haven't ever done one like this before, but it is a binomial squared, and so in order to do that, we could use a box problem. And so we have the square root of 7x and the square root of 7 and x. So the square root of 7 times the square root of 7 would be the square root of 49. 7 times 7 is 49. And this is square root of 7 times x. And this is the square root of 7 times x. And this would be x squared. Well, what is that when you simplify it? Well, let's put this term first because we usually put the squared term first. Do you see right here we have two of the same thing? We have 2 square roots of 7 times x. And what's the square root of 49? And that's it. We hope we don't have a lot of those because those are ugly. Right? That's an ugly looking answer. But we have not solved anything yet. So now let's look. Those are just some skills we're going to need when we do solve some radical equations. So 2x plus 3 equals 5. This is a radical equation because it has a square root in it. It's an equation because it has an equal sign. So we're going to solve it for x. When you are solving a radical equation, the first step is to isolate the square root. Is this square root on one side of the equal sign by itself? That's what we want. And then, in order to solve it, we're going to square both sides. Why would we square both sides? Because the square and the square root are going to cancel each other out. And so we square both sides and we get 2x plus 3 equals 25. And then we solve it by subtracting 3 from both sides. And divide both sides by 2. And what is x equal to? Maybe. We must check, because there could be what's called extraneous solutions. You've heard of extraneous solutions before, but it's been a while. Extraneous would be an extra answer that looks like it's the right answer because we didn't make any algebra mistakes, but when we substitute it back in, it does not make a true math sentence. So the original problem was 2x, and I'm going to put in the 11, plus 3. Is that equal to positive 5? So that would be 22 plus 3. Is this equal to positive 5? So that means that 11 is the solution. Three equals x plus the square root of x minus 1. To solve a radical equation, the first thing I need to do is to isolate this radical. It needs to be by itself on one side of the equal sign. And so I need to subtract x from both sides of the equal sign so that x minus 1 with a square root is on one side of the equal sign by itself. And then I need to get this x out from under the square root sign so that I can solve for it. How would that happen? I square both sides so that the square and the square root cancel each other out. But on this side, I need to square a binomial. 3 times 3 is 9, minus 3x, minus 3x. Minus times a minus makes a plus x squared. And so when I combine like terms, x squared minus 6x plus 9 equals x minus 1. Now what? It is a quadratic. We know 3 ways to solve a quadratic. We can solve by factoring, we can solve by the quadratic formula, and we can solve by completing the square. The easiest way to solve it is by factoring if it will factor. If it will factor, or if I'm going to use the quadratic formula, it has to be equal to 0. So I need to subtract x from both sides and add 1 to both sides so that it will be equal to 0. X squared minus 7x plus 10. The factors of 10 are 1 and 10, of course, and 5 and 2. So if we put the signs in like this, would that add up to equal a negative 7? Would it negative 5 times negative 2 multiply for a positive 10? Those are not the answers yet. X minus 5 equals 0. X minus 2 equals 0. X equals 5. Add 5 to both sides. X equals 2. We have 2 answers. Guess what that also means? We're going to have 2 checks because we have 2 answers. And so we're going to have to check both answers, because what can happen is one of the answers might be an answer and one of them might be extraneous. So I go back to my original equation, and in place of the x, I put 5s. So this would be 3 equals 5 plus the square root of 4. 3 equals 5 plus 2. I don't think so. Do you think so? And I don't have a sign list. Okay. So my next one. 3 equals 2 plus 2 subtract 1 underneath the radical sign. 3 equals 2 plus the square root of 1. What is the square root of 1? So what does that mean? It means this number is extraneous and this number is a solution. When I substituted the 2 in, it checked out. When I substituted the 5 in, it did not check out. Okay, we have the square root of x plus 1 equals 5x minus 1. How many square roots do I have in this problem? See 2 of them? Do I have the same numbers under the square root? I have an x and I have a 1, but they're not exactly the same because one says plus 1 and one says minus 1. It doesn't have the same radicand, the same thing underneath the radical sign. So there's no way I can isolate the radical because I have 2 of them. If I have 2 radicals, I want 1 on each side of the equal sign. Do I have 1 on each side of the equal sign? That's what I need if I have 2 radicals. If they're on the same side of the equal sign, I have to subtract one of them so that they're on opposite sides of the equal sign. And then, when they're on opposite sides of the equal sign, I need to square both sides. What do the square and the square root do? Now, you see this 5 out in front? You see that I put parentheses around the whole thing? The 5 out in front gets squared because all of this gets squared and it's not under the radical. So what is 5 squared? And then this square and square root cancel each other out. What do I do with that 25 out in front? So I have 25x minus 25. Now, on the previous problem, I had a quadratic equation so that I had to make it equal to 0 and solve it. Is this a quadratic equation? Do we have any x squareds here? No, so I just need to combine like terms, subtract x from both sides. 24x minus, ooh, this is going to be ugly, isn't it? I didn't make any sign mistake there, did I? And so why am I going to say this is ugly? What am I going to have to do next? It's already subtracted. What's the opposite? And so this is going to be 26 equals 24x. What's that going to be? No, it's not. It's going to be a fraction. So that is going to be the fraction here. And we need to check that fraction. Ooh, my goodness, that's going to be ugly. Okay, so you must check for extraneous solutions. And so if we check for extraneous solutions, how do we check for extraneous solutions? We plug it back into the original equation, but we have to plug in a fraction. And so the fraction has a denominator of what? 24. So I'm going to plug in 26 over 24. Plus 1. In order to add fractions, they have to have a common denominator, so this needs to be 24 over 24. And this is going to be 26, 24, my possible answer, plus 24 over 24. Oh, yes, thank you. I knew something didn't look right about that. That would be a minus. And so this is going to be nope, that's going to be 50 over 24 equals 26 minus 24. Are they equal? I think we better grab a calculator to check and see if these are equal because they're so ugly. So how would we do that? Where is my calculator? And so for my calculator here, I am going to use Desmos, and we have the square root of 50 divided by 24. Is that the first one? My typing's bad. Did I type it correctly? And then the second one is 5 times 2 square roots of 24. And do my decimal numbers match? And what does that tell me? That even though those are ugly answers, it does in fact check out. And so that means this is a solution. It is not an extraneous solution. My next example . Okay, if I have one radical sign, I need to isolate this radical sign. If I have two radical signs, I need to get them on opposite sides of the equal sign like I had in my previous problem. So I'm going to add 3 to both sides. And so then I would have 4 square roots of x equals 3. It's not isolated yet. It has a 4 out in front. The 4 is multiplied. The opposite is to divide. So we have square root of x equals 3 over 4. Now what? square both sides. Now that's not as hard to do as it looks. To square a fraction, you square the top number and you square the bottom number. To square a fraction, you square the 3 and you square the 4. And then we need to check. 4 times the square root of 9 over 16 minus 3 equals 0. Well, 9 and 16 are both perfect square numbers, so this is equal to 3/4 when you take the square root of it. The 4's will cancel, and you have 3 subtract 3. That does check out. That means this is a solution, and there are no extraneous solutions. So, what do you do first? This needs to be isolated. So this is a negative 2x. So the opposite of that is plus 2x on both sides. 15x plus 10 equals 2x plus 3. Now we have the square root isolated on one side, so we can square both sides. The square and the square root cancel each other out. This is squaring a binomial, so I'm going to go over here where I have a little bit of space in my margin and do 2x plus 3, 2x plus 3. 3 times 2, 6x. 3 times 3 is 9. We've done enough of those that maybe you would be able to start multiplying those out in your head without a box problem. What kind of problem is this? I see the x is squared. That means I need to make it equal to 0 and see if I can factor it. Zero equals 4x squared minus 3x minus 1. Since this is not 1, we're going to have to use our long factoring. Do we remember factor by grouping? Multiply the first number times the last number and get the factors of 4. That would be 1 and 4 or 2 and 2. If I put the signs in like that, they multiply for a negative 4 and they add to get a negative 3. Do you remember factor by grouping? 4x squared plus 1x minus 4x minus 1. The GCF of this group would be x. The GCF of this group would be minus 1. So 0 equals x, 4x plus 1. 0 equals 4x plus 1, x minus 1. I'm waiting a minute for you to catch up with your writing. Using the zero property rule, either the first factor equals 0 or the second factor equals 0. Subtract 1 from both sides and divide by 4 and add 1 to both sides. So we have 2 answers. If we have 2 answers, what else do we need? 2 checks. So now we need to check it. If you have 2 answers, then you must have 2 checks. What can happen in this case, they both checked out, and so we have 2 solutions. Sometimes one checks out and one's not, and then you have an extraneous solution. Occasionally, neither one of them will check out, and you have no solution. So, what I want you to do is write down these steps for solving a radical equation. Where'd my steps go? Write down these steps for solving a radical equation.